Hi everybody. Let us solve one of the problem from finite element method or finite element analysis. So let us start with the problem. For a triangular element, obtain strain displacement relation matrix, that is B matrix, and strains epsilon x, epsilon y and gamma xy. So this is the given triangular element. So global coordinate x and y, element node 1, node 2, node 3. So at node 1 x1 is 1, y1 is 1, x2 is 8, y2 is 4, and x3 is 2, y3 is 7. So with respect to these three nodes, they have given the displacement q1 in the direction of x, q2 in the direction of y. Similarly, q3, q4, displacement q5 and q6. There are 6 displacements, and the values of this displacements are being given here in this equation, this data, in the given data. So see the derivation of these equations, whichever I am using here, it is they derived in the theoretical part. Derivation of strain matrix for CST elements, that is constant strain triangle element, that is CST element. They have given the explanation, and they have derived how this comes. So initially, the solution, as a solution part here, x1, x2, x3, y1, y2, y3 values are given here at node 1, node 2, node 3, x1, y1, x2, y2, x3, y3 they have given. So we have to note it down. So initially, the j, determinant of j, that is x13, y13, x23, y23 they have given. So the cofactor of this becomes j is equal to y 23 minus x23 minus y13 minus x13. This is the cofactor of this one. After the cofactor, the adjoint of j will become is equal to, see, the adjoint will become y23 minus y13 minus x23 minus x13. Okay, this will be the adjoint of adjoint of this cofactor. Okay, so y23 minus y13 minus x23 plus x13 is the adjoint. Okay, so next, so we don't have values of y23 minus y13 minus x23 and x13. So we have to find out the values of these x and y. So for x3 initially, that is equal to x1 minus x3 equal to, so x1 value is here, x3 value is here, substitute it and get the value. Similarly, x2 minus x3, that is this one, and y13 y13 is equal to y1 minus y3, y23 is equal to y2 minus y3. All these values we have received now here. So next, substitute the result what you have got to this in the respective place. That is x13 is minus 1, y13 is minus 6, and x23 is 6, and y23 is minus 3. So calculate the j value by this way, cross multiplying. You might be knowing this. So the strain, that is j inverse, is equal to 1 by j into y23 minus y13 minus x23 into x13, the cofactor which you have written here, that is the thing, the adjoint, the adjoint what you have written here, that you have to use here. J inverse is equal to 1 by determinant of J into the adjoint of this adjoint. So into Q1 minus Q5 and Q3 minus Q5. So this is the derivation part, please go through that and see here. By now epsilon x is equal to 1 by determinant of J into y23 into this one Q1 minus Q5 and minus y13 into Q3 minus Q5. So to determine epsilon x, we are considering y terms. Okay, to determine epsilon y, we are using x term. I'll tell you how it will come. So y23 into Q1, y23 symbol is minus, so minus y23 Q5 minus y13 Q3, minus of minus is plus y13 Q5. So now we have to avoid this minus term here, sign, minus sign we have to avoid. For that, what we are going to do is, see, this one minus y13 we have there, so is equal to minus of y1 minus y3, which we have done initially to calculate determinant of J. You might be knowing that. See here what we have done. Similarly, I am carrying out the process. So you have to split it and you will get y131 in the place of minus y13 you will get y31, it is plus sign. So similarly y13 minus y23, substitute this and you will end up with y12. Okay, so minus term we have to avoid. Y13 minus y23, why? Because see here q5 it is plus y13 minus y23, so q5 out, q5 into y13 minus y23. Okay, that's what I have written here. Okay, so at the end what you get for epsilon as x equal to 1 by determinant of J into y23 q1 plus y31 q3 plus y12 q5. Anyhow, you have got all the values now, it's all in your hand now. Substitute it, this values of these things and get epsilon x answer. Similarly for epsilon y, I'll show how this comes. See here, for epsilon y we are considering only x terms is equal to 1 by determinant of J into, this is the same I have written over there, but here instead of odd number, even numbers come. There odd number occurred, here even number is occurring. So q2 minus q6, q4 minus q6, same, minus x23 into q2 minus q6 plus x13 into q4 minus q6. Simplifying, bringing this q2 q6 and q4 q6 outside, multiplying with the x13 and this one. So similarly you have to carry out and you have to avoid negative sign. For that I have done some necessary step here. You have to avoid negative sign in order to get the positive sign, so I have done this step. Okay, see this, similar to epsilon x. So now after simplifying, substitute similar to the epsilon x you carry out and you will get this epsilon y value. So now gamma xy is equal to del u by del y plus del v by del x. For that, see, 1 by J, determinant J into this thing, this equation. For that one where I have shown you for this. Okay, and gamma xy is equal to 1 by determinant of J into everything you have to write, whatever the term you have received, everything you have to write, because here the equation is like that, del u by del y plus del v by del x. Then bring them out of the bracket, and now by this time you will be knowing minus x2 is x32, because you have done the necessary arrangement to avoid negative signs everywhere. You have done some necessary required conversion in your previous step, so you directly keep on use them. Okay, and you can substitute them here. So at the end you substitute all the values and you will get gamma xy answer. Okay, next epsilon is equal to epsilon x, epsilon y, gamma xy. Put all the values together. It's your answer for second question. Here what second question is, the second question, strains epsilon x, epsilon y, gamma xy. So for them this is the answer. Okay, and next strain matrix for 2D triangular element, that is epsilon is equal to b into q. Okay, so this is your B matrix. Remember, this is your B matrix. You have to remember, this is in your derivation part, so please find that this is your B matrix. Okay, see here, y23 0, y31 0, y12 0, 0, x32 0, x13 0, x21, x32, y23, x13, y13, y31, x21, y12. So this is your B matrix. Substitute the values, substitute this B matrix values, that is sufficient. They asked only to find B matrix, so this is your B matrix. If you do this, that is sufficient for you. Thank you.